Now let's look at what happens when we're trying to optimize distance problems. There are a couple tricks that will help you. You're going to be given some function f, and you're going to be given some point x naught, y, and you're going to need to minimize the distance from this point to a point on the curve, and the point on the curve is x, y. Now, you know the distance formula is the square root of x minus x naught quantity squared plus y minus y naught squared. Now, the trick here is you need to observe that this function right here is minimized at the exact same point that the inside is minimized. So we're going to use this trick when we're trying to minimize this distance, because this is easier to take the derivative of than this. Will this work? Yes. Let's have a problem here. Which points on the graph y equals 4 minus x squared are closest to the point 0, 2? Now what am I given? I'm given the point 0, 2. I'm given the formula, but I'm going to put that somewhere else in a minute. I've got my sketch. Unknown. What am I looking for? I am looking for a minimized distance. So that tells me I'm going to need to use the distance formula. Now, the equations are kind of fun for this one. This equation right here is your secondary equation. So y equals 4 minus x squared is your secondary equation. Your primary equation is your distance formula. D equals the square root of x minus 0 squared plus y minus 2 squared, because that is the distance from this point to the curve. But remember, I don't want to take the derivative of the square root, so I'm going to make it a capital D, and this actually makes it easier when you're shoving it in the derivative anyway. And this is x squared plus y minus 2 squared. Now, let's do some manipulation. I need to take and put my secondary equation into my primary equation. So instead of D, let's go on and use D. That's all right, I'll show you something here in a second. This is x squared plus 4 minus x squared squared. Now, I'm going to simplify this out to x to the 4th minus 3x squared plus 4. All right, so this is my function that I'm going to need to take the derivative of. Come over here. Now, the next thing you need to do is take the derivative with respect to x of d, and that is going to be 4x cubed minus 6x. And we need to set this equal to 0, so we need to factor it. So when we factor, it's 2x times 2x squared. Let me back that up. So it's 2x times 2x squared minus 3 equals 0. So what are my critical points? X equals 0 and plus or minus the square root of 3 over 2. Now, let's check the first derivative test to see whether these are maxes and mins. All right, for x equals 0, all right, if I'm less than 0, this is negative, and this is negative, so this is going to be positive. If x is greater than 0, this is positive, this is still negative, so this will be negative. So by the first derivative test, this tells me this is a maximum and not a minimum. Now let's check x equal the square root of 3 over 2. And so if x is right to the left of the square root of 3 over 2, say between 0 and square root of 3 over 2, this is positive, and this number right here is negative. So this will be negative. If we are between square root of, greater than square root of 3 over 2, this is going to be positive, and this is going to be positive, so my slope is a positive. So I get, by the first derivative test, this is a minimum. And similarly, when x is minus the square root of 3 over 2, it's a minimum. So the answer is what points, because you have to go and answer the question asked. We're looking for the points. So I guess that should have been my unknown, was the points with minimum distance, shouldn't it? Are going to be, put it here, the x value is the square root of 3 over 2, and then the y value is 5/2. And the other point is minus square root of 3 over 2, and my y value is 5/2.